Um, I guess what today's topic, major topic, is called reduction of states. Unfortunately, the state diagram that we had last week, Friday, looked like it got deleted by accident. So, as an exercise, we could just go back. What were inputs again? So that input was any switch or any thing that is going to be activated.
Stop. Inlet.
It's an out. Anything that is going to be turned on or activated, that is an out.
So what about the switch level?
The level switch. So those are our inputs. Tell me what will be our outputs.
Sir, I forgot the stirrer as an input.
Okay, now. I look.
Outlet. So outlet, yeah, the outlet as an output.
All right. So outlet as an out. And we said that the states would represent the different things that are turned on in the system. So we're saying that the inlet the first thing after we press the start switch, the inlet on is one state of the system. And then the stirrer on is one state, next state of the system. And then the outlet on is the next state in the system. So we were saying that inlet on was 0, 0, 1. Outlet on is 0, 1, 0. And the outlet stirrer on is 0, 1, 0. And the outlet on is.
Yes, sir. And also everything off.
All right.
0, 0.
All right, so that would be all three of the outputs. And we were saying that we would let the inlet, this output, we assign a binary value for the output. So would give each a binary value. And then we said that they are.
Sorry, wouldn't that be 0, 1, 1 instead of 1, 0, 0?
No, we're saying that we're making it the same as the state. For convenience.
All right, sir.
We could make it 0, 1, 1, but for convenience, we're making it 0. So this was what we were working with somewhat. And so from that, we draw a state diagram. And state diagram, we said that you had your 4 states. So 0, 0, 0, 0, 0, 1, 1, 0, 0. Sorry. 0, 1, 0, or 1, 0, 0. And our output was the same thing as the state. And so we put our output as single lines. And then what we said we did now is that we look at each state. And if you press, for example, if you're in everything off and you press the start button, then you will go to next state. If you press the stop button, then you stay in that state. So 0, 1, and so if you're in state and you press and the level switch will carry us to the next state, and then here, sorry, not the record, and then the stereo will carry us to the next state. And in each of these states, 0, 1 would keep us, if you press the start button, 0, 1 would keep us in the same loop. Yeah, so it's supposed to be 0, 0. Sorry. This wrong. It's supposed to be if you press the start button, you're in the same state. If you press the stop button, you would go back to the original state. So this was a state diagram. And from the state diagram, we drew our table, and then we use the table to go. So now, the topic for today is that we can reduce the number of states, or well, it's called a number of states, but instead of having, because it's 3 digits that we're using, so it's 3 flip-flops that we would need. And the circuit would have to be simplified for the 3 flip-flops. So what I want to talk about now is, before we talk about reducing states, you have ever seen a thing called an encoder, a decoder? I heard about it in digital class.
Yes, sir.
Tell me how it go.
As in what it is?
Yeah.
So they were opposite kind of, they change the decoder and change a 4-bit to connect to like a 7-segment display.
So basically, you can use a decoder to implement any function. That's how it goes.
All right. So here is the thing now. Your decoder you can have a 8 to 3, 4 to 2, 16 to 4, and those kind of things, decoder circuit. So what did this decoder circuit is supposed to do? Let us say that we have input A, B, C, D in our encoder. When A is on and everything else is off, then a certain value is selected at the output of the encoder. When B is on, then another value is selected at the decoder, and so forth at the encoder, and so forth and so on. So whenever any one of these items is on, then the value is encoded and sent out. So that is why we are saying now that when we start switch, we're giving it 0, value. So our start switch, if we put the inputs of that we have to an encoder, then whenever any one of them is high, then the output will go to the value that we selected here. But converse of that is a decoder. Now, if I have a decoder, then 0 is going to select one of these outputs, A, B, C, or D, to be on. And that is what we are going to use to talk about now. So that if we have here, we have 4 states of the system. So the 4 states can be encoded. So Friday, I was just saying the inlet on is 3 flip-flops. You're going to have, so the one flip-flop is going to tell you that the inlet is on, is going to turn on the inlet. One flip-flop is going to turn on the stirrer. One flip-flop. So in other words, we have our 3 flip-flops. And one of them is connected to the inlet. Always, one of them is connected to the stirrer. We turn on the stirrer. And one of them is going to turn on the outlet. And if all of them off, everything is off. But what we are saying now is that instead of doing that, we can cut out one of the flip-flops and just put everything, our output to encoder. So I'm going to know, since it's 4 states we have, I'm going to call the inlet on state 0. Well, let me call everything off 0. The inlet on 0, stirrer on 1, 0, and the outlet on 1, 1. So I'm going to use that. So that means that what I'm going to do at the end of that is put the outputs. Like I said, no, we're not going to use, we're going to put the outputs to an encoder, and it's going to select to turn on one of these. All right. So we're going to do back over the circuit, and we are going to simplify. Okay, so now we're still keeping so our state is everything off. We're calling that 0, 0. Our state with the inlet on is 0, 1. Stir on is 1, 0. And the outlet on is 1, 1. So now, so we're keeping everything as the same. But what we're doing is that we are giving each state a binary input, a binary values. 4 states we have, so therefore we can use these binary values that we have here. So now, so let's draw up the table again.
Sir, just one sec. Go back a little bit for me, please. So you change. So initially for the state, right, we have inlet on, stir on. They have 0, 0, 1. You actually changing those values.
So the values in red.
Okay, all right.
Because in the outset, we said inlet on was going to be one of the flip-flops when to turn it on, stir on one of the flip-flops when to turn it on, and so forth.
Okay.
But let's attach it to a binary value. And what we're saying now, we can just attach it to a decoder, and it will pick
Whichever one.
whichever one we want to turn on first. So we don't have to specifically do it in the. So once again, we have I1, I2, but this time we only have A and B. And then we have A star, that is the next state. JA, KA, JB, KB. And we fill in so this time now, we are only filling in 16 values. All right, so let me etc. So let me go to the Excel. Wait a second. Oh. All right, so this was the sheet that we had the last time. So what we are saying is that we can have the same sheet, but we can delete some things out of it. So we delete in C. We are doing it the lazy way. Although I think the lazy way catch up with me. All right, 4 zeros, 1. So I was deleting the parts that go. Oh, we have a problem. All right, so now, so this is almost our new table, 0, 0. So we have to make some changes. 1, 1, 0, 1, 1. All right. But remember the excitation table? How this go again?
So for 0, 0 for J, 0 and X for K. Then 1X, then X1 and X0.
All right, so let's check. A 0 to 0. JA is 0. X. B is 0 to 0, so it's 0x. A is 0. be 0, so that's 0x. 1 to 0, 1 to 0, x1. Third, a is 1, x8 is 0. That's, don't care. 1. B is 0. That would be 0, don't care. We don't care here. A0, star 0, 0 don't care, 0 don't care. All right, 0 or 1, sorry, 0 and 0, 0 don't care. 1 to 0 is going to be don't care. 1, A is 1, 1 to 0. 1 to 0 is don't care. 1, 0 to 1 is 1 don't care. A is 1, A star, okay. That is don't care. A is 0. All right, that's okay as well. A is 0, 0, 0 don't care. 1, 1 don't care. 0. 1, okay, that's don't care. 1, that's don't care. That's don't care. That's don't care. 1 to 1, that's don't care. 0, 0 to 0. That's 0 don't care. Okay, so that would be our table. Just check it through, please. And then, so our simplification would be much easier. Because we only have 16 values. Thing is acting up again. Give me a second here. logic converter is acting up again. Sure. Anybody have a copy of Multisim? Accessing.
Then we have Multisim and Proteus. And Logisim.
All right, so you can open Multisim and do this simplification, share it on your screen.
Say it again, sir.
No, I was asking if you can open Multisim and do the simplification and share.
Simplification.
Simplification of the two tables that we have.
What?
I think build the circuit, sir, and then plug in the values.
Do the truth table. Check out the logic converter.
Oh, Multisim could I do that?
The only reason I use electronic workbench is because it is a simple version of Multisim.
Where it says, sir,
All right,
must we bring up, sir, logic converter or what?
logic.
For the
Bring a Multisim.
Alright. Grant me the permission to share screen, sir.
All right.
Chapter 167. Knowledge is power. The moment they entered, the heaven and earth trembled.
Oh, come on, somewhere over there. I get the permission, sir.
No, wait. We'll try to find where is
Oh,
it.
yeah. Yeah, so I can try with Logisim, you know. I have Logisim, so I think it would be easier with Logisim for true.
All right.
So I have Multisim up, Logisim at the same time.
I just wanted to show you.
There is
Your screen.
hold on, sir. Hold on.
Let's see here.
I'm gonna start sharing.
Oh, yeah, you can share your screen.
All right, Logisim. All right.
Somebody.
Screen. Sir, I still have the permission to share screen.
Oh, wait there. You know, I've been with this stripping this video, you know. He thinks
So you know, Logisim, I think it would be easier with Logisim for true.
so bring up whichever one.
I bring up Logisim, sir.
All right.
Window Logisim. All right. Share. Seeing the screen, sir?
Yeah.
All right, give me a sec. You seen the comment? All right. Stimulate window combination analysis. All right, sir, what's the input?
All right. So the first one
Is A, B, how much input, sir? 4?
Yeah, 4 inputs.
B, C and D. All right, and the output. What's the output now, sir?
JA, JB,
J A
KA,
B.
sorry, JA, KA, JB, KB.
All right, I'll remove this. J A K A B B K B.
JB.
All right. Do we have an expression, sir?
No, it's a true table. Yeah.
All right. So ready now. Just tell me the values now, sir.
Give me a second. You have to minimize the screen. All right. So the first, so you have, so for the first one, JA, 2 zeros,
Yeah. Uh-huh.
then 2 don't care,
Wait. J A 0. K A 0.
no,
JB is okay.
no, I'm filling out the column for JA first.
Oh, so it's 0. Oh, going down.
Yeah.
0 0.
Don't care,
So XX
0 0,
0 0.
XXX, 3 X's,
All right.
0,
XX 0.
and then X's, don't cares, go finish the table.
All right. Next JA KA, I should say.
We're supposed to see something on the screen?
Yeah, but that's not the door, by the way.
Oh, you're not seeing no.
We just see the screen. We bring up the screen and that's it. We also not that's after that.
I have no. So you not see the combination of
No,
the two table screen.
no, nothing.
It should,
Because
it
it
should
is a
be.
pop-up, you'd have to share your entire screen for us to see it.
All right. Let me switch it. I'm gonna switch it to
Make
share
sure it's in
the.
on the port.
No what? It's a support.
Yeah, make sure you're not on the port on the screen and then share.
That has been happening a lot.
Oh boy. All right. You guys seen the screen? The entire screen? All right. Good.
Yeah.
That one thing with that four about pouring. Thumbs up there. All right.
Right. Where you're seeing it, where it has been popping up.
So you see this now, sir?
Yeah.
All right. So KA
KA now. KA, don't care.
Oh, so the first one is don't care.
Second one is don't,
Third one.
1,
Mm-hmm.
3 don't cares,
3 don't cares.
1. You don't need to see before. Oh yeah, yes you do. 3 don't cares, then 1,
Uh-huh.
then just fill in pair don't cares. To the
So
second,
X comma 0.
to the second to last one is a 0 and then a don't care.
So wait. The second to last one. Right here? A
Yeah.
lot, no?
Right, second to last one is a 0 and then you don't care.
Okay. JB, no?
JB, 0 don't care, 0 don't care, 0 don't
0. Don't care. 0 don't care.
0 don't care.
Then so 0x0x0.
X.
0. That's the next one after that.
0x, 0x, 1x,
This one is 1.
and then x. Everything else is x straight down to
straight down to
Second to last one. Same thing again. A 0 and a X.
right there.
Yeah.
All right, so this all right?
Yeah.
Okay. Next.
Don't care one.
1.
There is don't care, don't care, don't care.
Then
1, don't care.
1. Mm-hmm.
And then don't care, don't care.
1. Don't care. Don't care. All right.
So you're feeling the don't care, don't care.
All the way down. And that's it.
Wait. Everything else is don't care. Wait. Start
There's
from the top.
X.
1.
1. Don't care. Don't care. Don't care. 1.
Mhm.
And everything after that is don't care.
Except 1, 2, 3, 4. The fifth one from the bottom is a 0.
Fifth one from the bottom.
Wait. 1, 2, 3, 4. 3. Where you are 1, 3 don't cares, and then the next one is a 0.
Wait, from here?
Yeah. So count 1, 2, 3 below the 1. 3 don't cares below the 1, and then
And then that's it. And then that's it.
Yeah.
Should I, what am I do now? Build a circuit now?
Yeah.
Alright. Should I?
Oh yeah, for me put the name.
Alright, let's just use that. Okay.
No, as in, you have to give it a name. Type in
Just
name.
give the circuit a name.
Oh, sorry, I never realized. Let's see. State change. Okay. That's how it look. Well, on this.
okay.
That means JA go forever be 0, sir.
Yeah, you have to just ground JA. Just put a ground on JA.
So what happen when I change the value? Everything change A, everything lock off. While everything is off, KA and KB is on. While these on, nothing really changed. These not connected now, sir.
Okay. D is what in our circuit again? D is the I1, I2, input 1, input 2.
But it's not connected now.
D is the output of this the last flip flop. J D is B. Do the next flip flop. So we're not connecting that. Remember now. All right. So remember now, the circuit that you're supposed to have is 2 flip flops. So and if you can use that, put the 2 flip flops. You can change the name to I1 and I2 for A and B.
Yeah, we can do that.
All right, so change the name from I1, I2, A and B.
So leave it
I1.
I1.
Next one is I2.
Oh,
Next one is A.
hold on. Oh, whenever I specify A.
No, that's I1.
Sorry. Rusty with large symbol now. Next one.
C now is A.
D or C?
A. Just C, change it to A.
Mm-hmm.
And D, change it to B. All right. So now you need 2 flip-flop, 2 JK flip-flop.
JK flip-flop, flip-flop, flip-flop. Oh, you want me insert 2 flip-flops, sir? Or
So
might not, this simulation is based on the truth table we created.
okay. All right.
So whatever is in this truth table, this is what Logisim gives you back.
Okay, so we want to just build a circuit here now. So we're creating
Unless we change all of these cues. In class.
sorry.
Unless we turn all these x's to zeros, that's the only way the circuit will fully connect.
All right, so keep the circuit. You can build another circuit now. Or
Yeah, can build another circuit, yes.
but how you save this circuit here, because this is the circuit that you're going to need to.
Don't worry about that, sir.
All right.
What we are calling a new circuit?
Mixing tank.
Mixing tank. Mixing tank. All right. Yes, sir.
So you need 2 flip-flop.
Oh, with Logisim, we don't servability as a servability from the beginning, but all right, I'll see. Do we have flip-flops? Should. Let me see.
Memory.
Oh, memory.
Mm.
That's it, huh? Yep. Which one I flip-flop? DT, JK,
JK.
or JK flip-flops. All right.
Trigger is trailing edge.
Hold on. Let me see if we can.
You see, I have trigger rising edge.
Yeah.
Trailing edge.
Sure. So is that a rising or falling? Give me.
Falling edge, trailing.
Oh, that's the next name for it.
Mm.
All right, sir. Anything? What else?
So we need another one.
So you want 2 JK?
Mm.
Why this guy expand, man? Oh well. Bring it over here, sir. Bring it over here, sir.
All right, so and you need the circuit that you build, the circuit out of the truth table. We need that there now.
Oh, you mean the original circuit?
Yeah.
See it here.
All right. So and then now you're going to the enable, you're going to need to connect a clock.
Clock.
8 multiplex, 8 plexers.
Think it's in this? Nope. Wait, try that again. Yes.
Wiring.
Probably not gate or plexus. It's in clock. Alright. For now, we'll just add them randomly. So.
Yeah, so put the clock to the enable.
The clock to the enable.
Mm-hmm.
Enable to the JK or the state change?
JK. It won't work unless you enable it.
May I try to find out which one are the enable? Ah.
Yeah.
This?
Yeah.
That trigger.
Same difference.
The trigger.
Mhm.
Job box cover one.
Hush.
The normal pain, sir.
Mm. I told them you have to check here.
Alright, we just like I said that, you know.
All right. So now your other circuit that you have there now.
This one.
Out of the queue for each of them,
The
you
Q.
need to put something to indicate
Output.
along. Yeah, output.
Okay.
Yeah.
Bring it up a bit. All right. Yeah, I need an output again. What is so? Sorry, no, I know your pain.
Okay. All right.
Yes, sir.
All right. So now your circuit that we just built a little while ago.
This one.
Yeah, that one. We need to connect up the JK to it.
Sir, what remember say one of the look here.
Mm.
I'm not sure. No, next. Remember say the B is still not connected here.
No, that's all right, man.
You sure? All
Yeah.
right. Got on the mixing tank, you know. It sure already, so. All right. So JB to what, sir?
All right. So now JA connect to the first flip flop up top.
To the J?
Yeah.
Oh, and JB to the second flip flop.
Yeah.
Oh, it makes sense. Say line right, sir. You know
Huh?
what that mean? Say line right, sir.
Mm.
You know what that mean?
Means that no connect.
All right.
And
First, I know what the second one goes, sir.
then, all right.
My roasty, but me not so roasty, sir. Cho. The clock now na input.
Clock suppose have an input. What is the frequency?
Oh crap. Be careful, I delete them somewhere. Remember why I'm not like circuit design now.
Push.
Uh,
All right.
one tick. High duration, one tick. Low duration, one tick. That's what the clock says.
One tick.
One tick, sir.
So you have to go, I think you have to go under simulate and then go upon tick frequency, you can actually change it.
Yeah, or you can just click on it. Or you can just click on it and change it manually. Next thing, sir. I need inputs, 4 input.
All right, no. So you need the 4 input.
So, alright. They're not now connect to the presets, the enable. Are they clear? For the J flip flop JK.
Let me with regular when you I'm trying because I hardly ever work with Logisim. I'm trying to remember if you have to enable the put a 1 and the enable for it to work. I think so.
Alright. We'll finish this first.
No, wait, you have 4 input
4 input.
and
I1, I2, AB. The 4 input. These are
I1, I2, AB. So what are the outputs?
the output are Q.
Okay.
Hold on. What was the output? All right. The output was okay. I shall label. Let me label them on. Can I continue talking, sir?
Okay. So okay. So AB supposed to be the same output at the flip flop. So A and B should be really connected to the flip flop. I1 and I2 independent, but A and B should be connected to the output of the flip flop. A should be connected to the first flip flop and B should be connected to the second flip flop. I don't know how you do it in a logic system.
Wait, the output as in this, right?
No, the Q output that you
Yeah.
have connected should be
Oh, you
connected.
want me? Okay. So my from the in. Alright, let's do this now. Alright, here.
And the next one connect to B.
No, you have to redraw the line. The theta shows you connect to J there. You look at that thing right there. So
Yeah, me correct it. The line here. Why?
just control V and undo until they get back to the line and they just redraw the line there. Simple as that.
Yeah,
Control V
yes.
and
Control what to undo?
Z. If our Windows you have to.
Yeah, man. Thanks. That work.
Like I said, I'm not helping much. I'm not used to Logisim. Used to the other two.
Go ahead, sir.
That sound like it can. That look like it connect to everything. You know?
That's what I'm saying. It was something I just
Undo it again.
irk me.
All right, connect the second one to B. And undo that.
Yeah, you should just come across the output yes and connect it to A, man. To the easier stuff still.
Yeah. When you say come cross, as in come from nowhere?
Yeah, no, no matter you could have come up by top and then cut across the output of the first circuit and connect it. We are connected to A, right?
Yeah.
Yeah, just cut no man, don't move that. Don't move that. Undo,
No,
undo.
just adjust that. No, just adjust it. No, okay.
Yeah, but that cause problem is that disconnect all of the output right there. So just undo it, undo. All right. Connect from Q, come up by top.
See what happens this as we start go down.
Then just click on Lego now and then yeah, let it go. Let it go right there. So and then draw next line then.
Alright. Right, that's it, not connect.
Yeah, blue line and show something like that.
Alright,
At the corner, you know, connect. Up at it, where up at the top.
right here.
Oh, up at it.
Yeah,
Okay.
up at it, yeah. Yeah, check it right. There you go.
Same thing. That's why I'm saying not to connect, sir.
All right. But
I'm trying.
What to do next, sir?
no, after you connect that, then you the simulator see when I1 is 0 or I2 is 0 and see if the outputs are working as well.
Well, go up on the state change circuit and see it and see maybe we can build it. I'm just screenshot it and then see if we can build it.
Yeah. So that's what we want. So you screenshot.
Yeah, you that.
It's not changing, sir.
No. So you have to build the circuit and then. So there's two more things we want to talk about though. Build that circuit there. Simplify it and then put together the circuit. And then you have to connect your output to a decoder. You see the Q them that you have?
Yeah.
The Q would have to be to a 2 to 4 decoder. Carry it up.
For the decoder.
Yeah, because remember, say Q is going to turn on the stir, the mixer, the different things. So
Yeah. 1 or 2 decoder, sir.
huh?
1 or 2.
When you say 1 or 2, what do you mean?
As in, you want, is it connected to one decoder or two?
One. What is that it must be a 2 to 4 decoder. How much bits input bits that have? Sorry, wait. Supposed to be an encoder then.
Encoder, oh, encoder, all right. Sector priority.
Yeah, well,
So okay.
how much inputs you have there?
It's a 3, but
Hmm.
yes, sir.
Yeah, well, see.
I don't know if it's over here is the input for this. Yeah, serve input.
Yeah, no man, 8 input.
Yeah, I was about to say 8.
Hmm.
If
And
you count the 0.
then,
Then
that's I needed a decoder then. That was correct. But the decoder was saying something that never.
up to right.
Yeah, it's supposed to have it have 3 input and 8 output. So I suppose they just use 2 inputs and make the third one permanently 0, and then use the 4 outputs. So here's, I don't know how you'd have to connect the same output lamps to the decoder to say that is to be connected to the mixer. That is to be connected to the, that is to be connected to the stir of output 1. Output 2 is to be connected to the, because we had said output is when you put over the other side, not that, leave out that, delete the priority encoder. It's for the first side. You see what the decoder say? You have 3 inputs.
Oh, it's the output. So, yeah. Oh,
Those are the outputs. Output 0.
I don't have a problem. That's better.
No man, why the output turn the other way?
Oh, you want it to turn the other way?
Mhm.
Okay.
All right. Now you see the outputs that you have: output 1, output 0, output 1, output
3. Go up to 4, son.
4.
Yeah.
All right. And so the inputs are what? Input. So the first input. Select, I did. All right. So you're supposed to connect the output of QA to the input of the decoder. That not the sir. That are the,
So this.
yeah,
So here.
yeah.
Oops.
And the second input connect to the next. All right.
You see that come back now, sir?
Mhm.
So do not connect to nothing. See that gear error? Because of the state change. Because this not connect to nothing here, you this. See?
Right. Right, but B do have to connect to nothing.
No, I'm gonna think that would affect it still. B that wouldn't affect it.
No, B just gonna change one it would be not affecting. Remember say that
Anything.
right.
Well, I'm going back on another. Yeah, make sense to that. I try to see if I can reconstruct it. So.
B is connected to what now?
B.
So
You have to tell me, sir, because I,
no, we're just finding out they need 3 outputs.
3, not 4.
3.
All right. 3.
The next one is off. Everything off. They don't. We had specified. No. Let me just go back. We had specified that when everything is 0, 0, then it's going to be off. I'm gonna sure say that output 0 is 0. All right, yeah, connect, put 4.
Starbucks, come on. Oh,
Gosh.
why, sir?
Mm.
No, I know the engineers and field.
You know, start it because when you finish and don't make sure it's everything work, then you have to go transfer it to a circuit board. So you have to do the printed circuit diagram.
Hey, I never believe nobody in them field, you know, sir.
Oh, okay.
In order for them make substantial progress or movement, the amount of stress them get.
Mm.
Some of them probably all through with them laptop couple times out of frustration.
Yeah. Part of life. But they say, here's the thing. Like I was telling the other class, yeah, I was telling the other class, I was telling you, I had gone to China.
Oh, I was there, sir. I was in the class.
And what
Girl,
I
I thought about
Chinese want to know is how to use these things.
so piece that thing here,
Mm.
this connection here. But you say that throw off the whole circuit, sir.
Yeah, cause I could reconstruct it still on my own green, so I don't know how I'm going with that. So probably something you need to check on it.
But I reconnect it still.
Well, if you decode that, is that 2-bit select bit that?
Yeah.
And the problem in the orange, I think the orange mean that I think is a mismatch, you know, because that I said 2 and the output we have a come out is a 1 bit. It tell us, yo, it no match right this time. So you see the orange line?
My time says a arrow, right? Just a arrow 1.
But this one I said before that. Yeah, before that. You see for the decoder, right? Where it's a 2. 2, that's 2 bit. You have a single bit connect to it, so that now go work right there, so. Because that's the select line, right? If you delete that leg, they realize the world the orange gone. Just delete the leg the way you have.
Yeah. But we don't need B in the circuit.
So we can delete these, sir.
Mm.
That's a yes?
Yeah.
I'll make it stay, enough to delete it. Just make it stay still. If it's part of the input, enough to delete it. Just ignore it. Well, I'll go up under the main circuit and we'll see mixing tank. Sir, but what's supposed to collect the decoder right there? So we have the select line.
Well, it's not one of those. Sorry, not one of them. The decoder we select our select line. It's just a two input or output decoder. So if the 0 0 come in, it's select the first line. It's not a select. Well,
So is that 2 state or 2 bit?
two input or output. So
2 in
select line,
okay.
the select line, if the select line is 1, how it's supposed to go now? Yeah, it will work. Sorry, it can work. If the select line is 1, it select output. If the select line is 0 and the other one is 0, it select the first one, and so forth and so on. So it's supposed to work.
Not now.
So my question is, why connect
Here,
Q?
yeah, go on.
Delete the line, the orange line underneath. Yeah. Why connect it? It's just the output of B. Oh.
Is it from here or from here?
Oh, QA was supposed to be the output of Q was supposed to be what is A. You know? The top one is supposed to be what is A, and the output of
Me take it out so if to get rid of the blue line and reconnect it again. Some connection is not work also.
Sir, me have the circuit. What may I try to figure out, sir, in terms of like for the decoder, like for the select line, right? The bits, it's supposed to be what, 2 bit wide?
2 bits. What? All right. Remember the screen a little bit. Explain how the decoder is supposed to work.
So how will we simulate it, sir?
Yeah, I understand. But there are some little things we need to sort out.
Yes, sir. Hold on.
Take back the screen. All right, so see every time we take back the screen.
Do you want to know, sir?
All right. So let me just go back to. All right. So the decoder, it is going to have 2 inputs. So there's A and B, and then one, and then it's going to select one of the outputs. So let's say Sarah inlet outlet so what I forgot which one I have there now, but what was let me go back up here. So all right, so this first state here, which is 0 1. 0 1, we did have the what is this now? The 001 was which one on? Inlet on. So 01 meant that the inlet was on. 10 said that the stirrer was on. And 11 meant that the outlet was on. So now, in all of this, what we are saying is that the truth table for these now is that you have your A and B as your inputs. So, and then your inlet is going to be on when it is when A is 0 and B is 1. So you're going to have that as the output for your first for your inlet. All right. So the 2 to 4 decoder was supposed to have two bits in and 4 inputs out, and it would select 0, 0 is supposed to select the first one. 0, 1 supposed to select the second one. 1, 0 supposed to select the third one. And 1, 1 supposed to select
Oh,
the
select the fourth one. Okay, so A and B really then is the really what control it. So it'll be connected to the select line then, sir.
right.
Okay.
So I was saying it would work if we have the select line.
So okay, yeah.
It can work with the select line and then B as the input.
Sir, I rebuild the circuit, but this time, I rebuild the first circuit, change with it from the truth table, but instead of having the don't cares, I change all of the don't cares to 0, and make it a completely different circuit.
Yeah.
It's same thing, same output, but all of them connected, all input connected.
Yeah, if you put all of them as 1, then you're gonna get a different circuit. So
No, I'm not put them as 1, I'm put them as 0.
if you put them
All
as
of the don't care, yeah, all of the don't care, just leave them in a state of 0, just say them off. It build a complete circuit.
okay. And it build a complete circuit. Share it now with us.
Sure. No, I'm not sharing right, sir. I have permission to share again, sir. All right. So this is what I did. I changed all the X's to zeros, and then I rebuild the circuit, and I got this. I just name it N. So from the JA automatically have a 0 there. So let's turn on A to see what happens when A turn on. Well, A would be I1 in what I said earlier. Not when B turn on or I2. Not when C turn on. Not really change. Change that. Hold on, let me simulate it. Well, it's simulated.
Remember, we did have some specific things, A, that is I1, I2. Check.
All right. KB turn on when B is on.
So
it turn off when C is on. KA turn on when A is on and everything else is off. What was the next case, sir? When I2 is on and A is on, KA and JB turn on.
All right. Mhm.
You seen it, sir?
Yeah.
All right. So I'm rename them. When I1, I2, and A is on, everything, the whole system turn off.
All right. Remember 00 is supposed to represent stop, and 01 supposed to represent start. But let me go back.
0, 0. All right. So 0, all right, 0, 0.
I2, sorry, I1 and I2 supposed to represent off.
All right, I1 and I2.
So
Off.
as it is here, put I2 as 1 now.
In a turn on.
No, you have to one of them here have to be on ARP. No change
All right.
A.
The change B, KB turn on.
And if you change, turn on A.
KA and JB turn on.
So what you need to do is check and see if the circuit that we have follow the pattern that is supposed to be there. What I mean is that the truth table that we have say that if I have certain changes that's supposed to occur. So see if it match the truth table.
So we have I1 off.
For example, the second line in your truth table. Second line in your truth table, 0001. So make everything 0 and turn on B and see if
Make everything 0 and turn on B.
and that is what's supposed to happen according to your truth table.
Yes.
And if you
That is
turn
what.
on A and turn off B, it's supposed to turn on KA.
Turn off. What is it? Turn off B. Turn on A. KA on.
Right. So you go through and match a truth table to your, say if you have 1, you look and see there, everything's supposed to off.
Mm.
It's supposed to be in the state of
Yes, sir. So JA will never be on. Based on the truth table.
all right. So there's
So
all
this. So
Say-
when I rebuild the circuit now, mixing tank. But I'm gonna remove this. I use the one where we just built and see if that works.
all right.
And then start stimulation. Oops. Delete. I'm gonna delete a while ago, sir. Let's go. All right.
By the way, like I say, I don't know if for the circuit you have to enable the flip flop.
I didn't put a one.
Huh?
I didn't put a one or
Mm-hmm.
0 feet.
Flip flop work because what it have there EN0.
Mm.
So it have a enable. And I don't know if it's active high or active low. So you probably have to put it to a high, a 1, to enable it to start work.
Yes, sir.
So remember the whole circuit building.
Huh?
The whole circuit build still.
Mm.
Is it working
Yeah.
with the neutral cable?
No, if it's don't care, I think don't care will affect the output in a say no matter if you change it to 0 or 1. So when you use the old one, everything will work still.
You want to share the circuit where you have?
Yep, can do that.
All right. We got now.
Alright, how this thing work now?
You have a click on share screen.
Now see it now?
Yeah.
Alright, some quick simulation enabled. The reason why them are blue is because it's disconnected the enable line and this up on 0, so it disables the output completely.
Okay.
So what's supposed to test the value then? Like a
So if you turn on I2,
mhm,
A,
A. Okay.
But the only thing is that the decoder thing supposed to connect to one supposed to connect to A and one supposed to connect to B.
Yeah, see there? It come through that split is a split of this and one connect with the A right here, so and then one connect with the B. So.
Okay. So change A to 0 and B to 1.
So A to 0 and B to 1.
I'm just seeing if anything come out of the decoder.
Yeah, the reason is that because all right, this output right here so connect to the enable, and because this state don't change, then basically that will cause the decoder to turn off. So now I wonder if this is supposed to connect right here, so you sure about the connection there? Got it.
You probably have to add some.
I
Try
probably
to see if you can enable.
the same thing like we do with connect it to A.
Connect it to A, the enable?
Yeah.
Okay, all right. So A, which one? Yeah, that one right. So.
Yeah.
All right. All right, so we'll try it again. Simulate. All right, so you turn on A, it actually come on.
Right now you have a decoder.
All right. Turn off B.
Turn off A.
B.
B.
All right. So it'll work, but we're not sure if it is working because
Correct.
I don't know if it is selecting the right
Line.
line. So we have to do the test and see which line is selected when for which values of I1 and I2. All right, because what's supposed to happen is that when the input is a particular value, like I2 is a particular value and A is a particular value, it's supposed to select a particular value in the output.
Right.
But I don't know what is the makeup of this decoder.
Oh, the decoder basically what it do, you know. All right, so when you have 0, 0, yeah. Go on.
All right, so go on. When you have 0, 0, everything off.
No, so when you have 0, 0, I think it's gonna be a problem, and the reason being is that all right, we have one of the input actually connected to the enable line, because with the enable line though, if the 0, it turn off the whole circuit, it no work. So I wonder if, hold on, if we put it, sorry, just do this. because we want the decoder to work at all times, right?
Mm.
So let's come back to our one, disconnect that. And then we'll try to output them now. So when we have, what go again?
1 I2 is 1, A change A to 0, change A to 1, change B to 1, change A to 0. All right. So with the different changes in the different outputs, it's selecting the different ones.
Right.
So if both A and B are 0, it's supposed to select 0.
Right.
So that should be everything off. Those are the three outputs below it.
Hold on, come again. When A and B and 0, everything's supposed to be off?
Yeah, the three. Remember, so the three below the first one. One represents the inlet. Not that first one, the one that you pointed to. The one below it. One is the inlet. One is the stirrer, and one is the outlet.
Oh, I'm just labeling it just so that we can follow up. So this the first one is what, inlet?
Yeah.
This the one here, which one?
Stirrer.
And the last one out again.
Outlet.
Outlet. All right.
So with A and B off, everything's supposed to off.
You're right. Inlet, stirrer, and outlet. So we know that accurate.
So now when B is 1, okay, we make both of them 1. Make so that is both of them 1, B is 1. Make A 0. No, the other way. Sorry, make A 1 and B 0. All right, so if you're connecting up the circuit now, what we had was that 1, 0 was the stirrer. So what you have
So 1, 0, 1, 0 is a stirrer?
Yeah.
Okay, so 1, 0, that'd be so 0, 0, 0, 1.
No, meaning A is 1 and B is 0. You understand? When A is 1 and B is 0, the stirrer is supposed to turn on.
Oh, okay. So when A is coming in, when A is 1
and B is 0, as you have it here,
the stirrer is supposed to turn on. Okay.
it's supposed to turn on. When
All
A
right.
is 0 and B is 1, so turn off A and turn on B.
Oh,
right.
so I think probably the next way around then.
Right. Turn on both of them now.
Like, yeah, the outlet. Yeah, no.
That is supposed to be outlet. So the inlet is supposed to be.
Switch around them here. Try it again now. All right, so when A is 1 and B is 0, it's supposed to get the what?
That is, the 0 and 1 supposed to give you the inlet.
0 and 1 get the inlet, right? 1 and 0 get a stirrer, like I didn't know.
And 1 and 1 supposed to give you outlet.
And I want to get the outlet, see that?
All right, so it's supposed to make those changes.
Yeah.
Okay. So that is the first part of the circuit. But now I just wanted to talk about one last thing, and then we try to put the circuit together. So we could just talk about one last thing. Totally unrelated, actually. Well, it is not totally unrelated, but unrelated to the circuit here. I want to talk about 555 timer.
Sorry, but a quick question though. Sorry, before you move on. What the purpose of the flip flops?
No, remember I said the flip-flops were that is your A and B is really flip if all right, go back to your go again. A and B.
The reason why I ask is because, all right, because even if we disconnect these two right here, right? Disconnect this right here. We still like get the same out, we still get the same results.
No, but the A and B that you're having is supposed to be coming from your flip-flop, you know. Your flip-flops are your A and your B. Your output.
Okay. So that means I'll actually have this set up wrong then. All right. Double talking.
That's why I was saying.
So this would be A and then this would probably B then, right?
Right.
So that was something like this. But then we wouldn't connect that right here. So
I don't think it is connected.
I'm trying to open them.
It's in between the stirrer and the inlet when the clock on. When you switch it.
One again.
When you switch it, before you turn off the simulator and you switch it to that, it was in between the inlet and the stirrer when the simulator on. Alright, turn on the simulator now. See that change?
Alright, but you're not supposed to change.
Yeah, not supposed to change. If we're not change the input right there, it's not supposed to change. That's our problem.
Alright, but to be honest though,
everything's supposed to on.
I'm so used to Logisim, so that's why I would prefer build the circuit to understand what is
yeah. Okay, that's it.
But after looking at it, and then Friday is the last time we talk about this. Like I said, I've given you the assignment today for you to put together. But what I would want, because after Friday this week, we will spend the time talking for the rest of the term talking about PLC, which is what is really what we just giving. Remember, so you're at a university, so apart from giving you what is the norm in industry, we have to give you an academic. We don't know who will work for NASA. We don't know who decides can't bother with this. We're gonna plant potato. So we have to teach everybody everything for eventualities. Like I said, one brother ended up in China, and because of him ending up in China from UTech, go do masters, me end up in China too. So there's no possibility in my life if I was living it over again that given the same set of circumstances that me know say me would have started up with first Chinese student teaching them electronics. Never in my lifetime. So you don't know where your life going to take you, and you don't know what. So you have to be prepared for every possibility.
True.
Right?
So there's only one barrier in the world, and that's language.
And it's not so much of a barrier when you take it into consideration. I always tell people that me used to pass UTech. I used to say, boy, me? Not even, I had a brethren who was at UTech, and I came over there one time. We didn't go UTech. I did over UTech. I really come to check Fitzy did the engineering. And I was terrified to walk by UTech campus because I said, suppose them know some come from UTech. Then probably go beat me, because there was no possibility in my life say I would ever end up at UTech. None. See that? Made up a UTech. Like this, the first time I walk by UTech campus, we go check my Bridget. Bridget say, come check me, man. Me look round because I say, them brother here. Pure bright youth and they might have say, look out of place. So you don't know where life will take you. Not weird, no shape, no form. No matter how much you plan carefully. Right? So that's why we say we have to teach you everything. I teach you all of the things. Because I didn't know that my knowledge would have carried me to China. And the strangest thing, this is some of the things that we take for granted. How we say Chinese people bright, don't it? Well, some of the things where we take for granted, them don't.
I never used to them bright, sir.
Huh?
I never used to them bright.
Yeah, man, I used to Chinese people. Chinese.
Them good with maths. That's all we can say, and calculation.
And
Because them basically go school like 6 days of the week.
Seven.
Right throughout the year.
Yeah. And
So something wrong with them, the intellectually up there. They go school.
Going school so long and so often has been proven to be a deterrent. They end up memorize too much memorization go on. So they have a problem.
Too much memorization, lack of experience, no fun, no relaxation, kill creativity.
No fun, no relaxation.
So no creativity ever go on. That's why them all the thing they want think about fast development and rapid expansion. But them country basically they have to wear a mask every day because of the overdeveloped. You understand, sir?
Because of the smog and everything.
Yes, you get me? And that's the problem. I know that some of them just leave them country. And then them procreate fast. So they're everywhere.
No, well, it's one child per couple, Them just change it, I think, to two.
Them a control them population because of them fast developed economy. Them a destroy the environment. I know them have a cut birth rate. In Jamaica, that now one family 10 pitney, and my grandmother a last of 14, sir. So imagine you come Ghana country there here say only can have 1 or 2 child per family. It's like murder. You cut off the ancestral line there, so.
Yeah. So, and then because they make the policy of 1 child per family, and they prefer to have boys, especially people in the rural areas, because they figure the boys help them more than girls. What happened is that they used to do the thing where they would, if the woman become pregnant, then they would make her do an ultrasound. And if it's a girl, they would have bought it. So now, the ratio of male to female in China, as a result of that, is 120,000 males for every 100,000 females. So there's 20,000 excess males for every 100,000 females. So, of course, that is a big demographic problem. Because the demographic problem that cause now is what then 20,000 man them are going to do. Not all of them are gay. So what those excess 20,000 man going to do?
Leave.
So that is why them now leaving China or exporting them from China all over the world. So the solution that them had to them population, it backfire on them. And them is a whole part of issues come up as a result of their solution to the problem. So sometimes when we think that this is the solution to the problem, it only creates another problem. down the road. So you have to be careful with because it was an engineering solution to the problem. So boy, population, all right, 1 child per family, that done. And then they never take into consideration their culture and all how people think and how people reason. 1 child, well, the 1 child, they always say, we want a boy, we don't want a girl. And then you create a big demographic problem. The other huge problem that they have is that when you have 1 child, they tend to spoil that child. So you have a whole group of spoiled men in a China. Spoiled rotten. So how the society cope with that is another thing. So you have 20,000 excess man and the other 100,000 where a woman, them spoil rotten. And the family them will have the girl and keep the girl, mix with the girl for the whole entire time because they did want a boy, but then they end up and keep the girl. And so it's a society with a whole heap of problems created by you're trying to solve this one problem. So you have to be careful. We as societies have to be careful of how we choose to solve our problems because we might be creating whole it down the road. So, but anyhow, that is still engineering, but different thing. All right. I'm going to leave the thing till Friday. They're talking about the 555 timer till Friday because that's the last thing on it. So after Friday, we're going to be talking about PLC. I'm not sure how we're going to work out the PLC. What is it? Everybody have a class 12. Some people have class 1 to 3.
12 to 3.
Huh?
12 to 3.
When
You have another class 12 to 3?
When?
I have this class.
Yes, sir.
12
12 to 3, sir.
12 to 3 when? Today?
Yeah, today.
Yes.
Is there
Yes.
another class? 12
My
to 3?
class is
Not
12